Hey kids, Mr. G here. Want to talk about fractions, and that's what we've been talking about the last couple of weeks in math. Now I know, when you get around the holiday time, you have that break time where you get extended time off, and you kind of forget some of the things that have happened in class. So I wanted to make this video to help kind of tie everything together. And so what we're going to talk about are comparing fractions. What is a fraction? Um, how do they work when you add them? Adding them with unlike denominators. There'll be a number of things that we'll cover on this. So as we move ahead, just want to give you this idea that comparing them could be done. Say fractions of money or clocks or in time, pizza, any type of thing. Probably thinking about lunchtime and foods and things like that. So we'll try to relate it to some things that you like. So what is a fraction? Well, as you know, the numerator at the top of a written fraction and the denominator at the bottom, those two together make up what is called a fraction. It means you have a part of a whole. So if you have half of a pizza, half of a dollar, half of a French silk pie, you're still a pretty lucky person. So, and then sometimes those halves or those fractions or those parts of a whole, you could have a part of a very small pizza or a part of a very large pizza. And you can compare those quantities to see which one actually is better for you and which one is truly larger or smaller. We can do halves through twelfths. We've gone halves through 50ths, through hundredths. We've gone and used thirds and quarters and fifths. And then we'd have related them to decimals when we start talking about money and coins and then how to write those. And of course, fraction circles and things, which are just like clocks and pizzas and things, we've used that. You also can look at 3/5 as being a division kind of statement. 3 divided by 5. And you don't always see the slash as a perfect a line, a horizontal line. Sometimes it can be at a diagonal, and that means division as well. So here's an area model. A fraction of this area is shaded. So it appears that 4 out of 9 are shaded red. Out of that bottom portion of the triangles, you have 2 out of 4 that are shaded. So therefore, you'd have 2/4, and up top, you'd have 4/9. And again, we've talked about making them as a division statement. 2/5 is measured in such a way where a 2 divided by 5, and you can convert that to decimals, which would be 0.40 or 40 hundredths or 40%. And so fractions, as you see down here, can be represented 10/13, 9/12, and so on. Common mistakes that we have, and they happen, and a lot of times it happens with new fraction users, but they may not accurately describe what's been shaded. 2 parts out of 4, they might just put 2 over 2. They might reverse things. I might not understand that the bigger piece is on the bottom of the fraction, the smaller piece is on top. If the larger piece is on top, the smaller, we call that an improper fraction, and we'll get into that later. Of course, there's a lot of different ways to practice. You can have different like color tokens and toys, and how many. Ask yourself questions and draw dots on a ruler. One thing we've talked about in class is having the old measuring tape, and this is a nice thing to be able to look at and say, "Yep, I can tell what's between 4 and 5, and I can see where the halfway point is. I can see quarters and I can see eighths." That's a great way to practice measuring things out. And also, IXL. There's a lot of computer programs out there that will help you. When we're comparing fractions, it's important to look at the fraction as a whole. If it's a mixed number, look at the large number on the side to see, sometimes 2.5. When you compare that to 5 1/3, people get fixed in with the half and the third, knowing that a third is smaller than a half. Well, sorry, folks, but 5 is larger than 2. So you have to make sure you're checking that out. There's 3 methods to take a look at things. There's the butterfly method, which kids Once they learn it, they like it. Using equivalents and then talking about clock fractions. The butterfly method. So you have 2/5 and 1/3. Well, you start at the bottom, start with the denominators. 5 times 1 is 5. And you can see where they wrote the 5. 3 times 2 is 6. Well, whichever number is larger, that's going to be the larger fraction. So you have to start at the bottom and butterfly it or crisscross it. And then you see which one's bigger and put the right sign there. Common mistakes is you start at the wrong place. You don't look at the numbers first. You're not finding the correct equivalents. There's mistakes. If you don't start at the bottom and work your way to the corners, you can make some common mistakes. But once you get the hang of it, it's pretty easy. Ordering fractions. Students will be ordering fractions. And as I said, being able to put fractions in order on a measuring tape, it's a pretty big deal, especially if you're going to be building something or having to find the correct materials and things that'll fit together, kind of like a puzzle. There's a lot of ordering fractions that go in with measuring things, but think of it as money, equivalent fractions, and reinforcing equivalent fractions. It's important to know when we start from least to greatest, which type of fraction is the smallest versus what's the largest. And it doesn't always mean that big numbers are the biggest fractions. So when we take a look at these fractions, 1/2, 2/5, 3/8, and you want to put those in order from least to greatest. 1/2 is like 50 cents. 2/5, you divide 100 by 5, and you have two parts. You have 40 out of 100, or 0.400. But 3/8, this goes with what I previously had said. The largest numbers aren't always the biggest fractions. 3 divided by 8, you get 375 thousandths. And so we all know that 1/2 is the biggest there. So when they went from least to greatest, that's one way to figure it out. Thinking that our fractions are like division problems. 1 divided by 2, 2 divided by 5, 3 divided by 8. We don't do those types of problems every day, but you have to be able to do that and know in your mind that that's how we work with fractions. They are parts of a whole number. And here's some of the common mistakes. Not properly looking at what their equivalent fractions might be, not putting them in the right order, and not using your calculator correctly, that kind of thing. Adding and subtracting fractions. And we've been using money, pizza, clock fractions, things to compare. We would like to have like denominators. Unlike denominators give us confusing work and confusing answers. We'd like to have like denominators on this. And of course, in word problems, it gives us its own unique challenge when you put the context around the fractions. Like denominators makes things real easy. 1/5 and 2/5 is 3/5. That's easy. You just carry across. That denominator is 5. Add the number on top. Boom, you're done. When you have unlike denominators, that's where I'd be willing to bet most kids get tripped up. You need to find a common denominator. 2/5 and 1/3. Well, some people will just say, multiply them together, and 5 times 3, you'll get 15. That's your new denominator. And that's a method to use, no question. Another method is the least common multiple method. Now, if you skip count by 3s, 3, 6, 9, 12, 15, and you could keep going and going and going. Skip count by 5s, 5, 10, 15, 20, 25. What you want to do is circle the number that's in both lists. And if you circle the smallest, take that smallest number, then you won't have to reduce the fraction later. It saves you a step. Our least common multiple here is 15. So 2/5 times 3, or 3/3, 3/3, gives us 6/15. What we've done is we've expanded that fraction. 2/5 times, it's basically one whole number, but 3/3 equals 6/15. 5 times 3 is 15. 2 times 3 is 6. What you're going to do to the bottom, you're going to do to the top. 1/3 times 5/5. 1 times 5 is 5. 3 times 5 is 15. Now you have a common denominator of 15ths. Okay, that's what the whole point of LCM, or least common multiple, was. You're listing out numbers to see which one is the least one they have in common, the smallest number they have in common. Change your denominator to that number. Then once you have the denominator change, the top has to change. That's this whole process right there. 5/15 plus 6/15 equals 11/15. Now you don't have anything to reduce because you went with the least common multiple. Word problems. Olivia made brownies for her family and she ate 1/3 of them. Her sister ate 1/6 of them and the brother ate 1/4. What fraction are left? So out of 3, 6, and 4, you're going to need to find the least common multiple there. Well, if you skip count by 3s, 3, 6, 9, 12. Skip count by 6s, 6, then 12. Skip count by 4s, 4, 8, 12. You'll notice that 12 is in all 3 skip counting lists. That's also the smallest number that's in both. That will be your new denominator. 1/3 will change into 4/12. It's just expanding it, not changing what it means or what the quantity is. 1/6 becomes 2/12. 1/4 becomes 3/12. And when you add all that, those top numbers of 4 and 2 and 3 get 9/12, which is the same as 3/4. So what is left? 3/12, or 1/4. Okay, so adding and subtracting fractions, it's very important that you're looking at your denominator, seeing if they match. If they don't match, and you can figure out a way to get them to match through the least common multiple method, or you could flat out multiply them out, but that's a lengthier method to use. Then you can find out your adding and subtracting sums and differences. Ways to practice this. Here's some ideas. Recipes are a great way to apply what you're learning. If you're going to make some cookies, make sure you add some for me, please. Equivalent fractions. We've compared fractions. We've done this. This is something that we've seen earlier, but just being able to change things to equivalent fractions. 6/15 is the same as 2/5. 1/3 is the same as 5/15. That kind of thing. Once you're able to really do that, then you'll feel real confident in being able to make those changes to add and subtract fractions that have different denominators. 1/2, 2/5, 3/8. This is what we had talked about earlier. You start counting out by 2s, by 5s, by 8s. You could sometimes end up with some kind of ugly denominators. I mean, 40ths, people don't use 40ths every day, but it's okay. It helps you solve this problem right here. 1/2 equals 20/40ths. 2/5 equals 16/40ths. 3/8 equals 15/40ths. It's just the same quantity, just divided into 40 pieces instead of 8. Anyway, if you miss any of the math that we've had over the last week to 10 days, this hopefully will help you refresh and get an idea of some of the things we're working with fractions, because I'll tell you what, there are times when just it helps to hear it again. And when you hear it again, sometimes it sinks in. Or if anything, use this and help you put yourself to sleep at night. I don't know. But anyway, I'm Mr. Garwaluk. I've been here to try to help you out with some fraction work. And I wish you the best of luck with changing fractions and expanding fractions and finding sums and differences. And have yourself a fantastic day. Thank you.